Hi there. Sometimes when we have a polynomial like this one, it's really hard to factor. So we use a little technique called substitution. So I'm going to let a equal x to the power of 4. So I'm going to rewrite my equation with a substituted for x to the power of 4. So I end up with a squared minus 5a plus 4. Now this is much easier to factor because we can use the product sum method here. And the product sum method has c as our product and b as our sum. So we need two factors of 4 that when added produce negative 5. And they would be negative 4 and negative 1. Those two values go straight into our bracket and form our factors. So we have a minus 4, a minus 1. But a wasn't in our original polynomial, so we now have to put our x to the power of 4 back in where a is. So we actually have x to the power of 4 minus 4 and x to the power of 4 minus 1. And these can be factored further. I'm going to take the first bracket and I'm going to factor that one. So x to the power of 4 minus 4 is what we call a difference of two squares, or dots, because we have two perfect squares being subtracted. The square root of x to the 4 is x squared, and the square root of 4 is 2. So I have x squared minus 2 and x squared plus 2. And taking the second factor there, or second bracket, I have x to the power of 4 minus 1, which is again a difference of two squares because I have two perfect squares. X squared is the square root of x to the power of 4. 1 is the square root of 1. Always. Any nth root of 1 is always 1. So there I have that one factored out. However, I can actually keep going with this one because right here I still have another difference of two squares. Because the square root of x squared is x, and the square root of 1 is 1, and it's being subtracted. So this actually becomes x minus 1, x plus 1, and this factor is still here, x squared plus 1. So our actual answer, if these two factors here, they cannot be factored any further, x2 minus 2 and x squared plus 2, as well as these three, x minus 1, x plus 1, and I'll put it over here, x squared plus 1. So our overall answer for factoring this polynomial is x squared plus 1, x squared minus 2, x squared plus 2, x minus 1, and x plus 1. And hopefully by using substitution you found that a little easier.